So phylogenetic trees are a useful thing to be able to interpret in the WACE exam as of 2025. The WACE exam no longer requires you to draw phylogenetic trees, but you should be able to interpret them. So what is a phylogenetic tree? Well, let's start by looking at one, okay? This here is a really basic phylogenetic tree showing how all of these species, A, B, C, D, and E, which we can see on the right-hand side, have diverged over time and can be traced back to a single point, which I'll draw here with red, and this is what we would refer to as the common ancestor. Now, this probably traces back way further in time, but for these 5 species of interest right now, A, B, C, D, and E, we're only interested in tracing it back a few generations here. Now we have some things to help us out. Along the bottom of the phylogenetic tree right now, we can see the progression of time. So we can see that over on the right, we have the present day species, so this is more modern, and we have the ancestors towards the left. At each point along the journey, you'll see there's a yellow dot up here from earlier. This here is what we refer to as a branch point, what I'm colouring over right now in orange. We have quite a few branch points all the way throughout this diagram. So these are our branch points. And what they provide are the branches themselves. And we can see the branches of different lengths all throughout this diagram here. And so what we can use a phylogenetic tree for is to compare, say, species A and species B, where is their most recent common ancestor? And what we can do is we can find that their most recent common ancestor is this one here. If I then wanted to compare A and C, I would need to trace it all the way back for both to when they had their most recent common ancestor. And if I wanted to compare, say, A and E, I would actually have to trace it all the way back to the last time their common ancestor was around up here. So on the next slide here, we have pretty much the same thing identically again. However, what we're focusing on now is this idea of the common ancestor. So this is what we've just annotated up on our diagram here. But if you're still struggling with that a little bit, you might like to pause it on this slide here to just go through in a little bit more detail. This here is just the different representations that you might see. So this is what we've seen. So this was just above, that was our example. All we've done in this middle one here is we've now flipped this tree so that it's vertical. As we look, this is the youngest or the modern day equivalent of these species, and this would be the oldest or the common ancestor. And finally, in the third example, if I just go 1, 2, and 3 really basically, instead of having these straight lines heading down, we've now got the lines on a slight diagonal as well, but it still shows the same information. So for instance, if I make a point of highlighting A's lineage right here, we can see that this line here, what I've just highlighted, represents the same information. Same way that I can draw E coming all the way down here, E comes all the way back through here as well. So our phylogenetic trees can be drawn in a few different ways, but they all represent the same information. So to look at some rules, what we had up on the screen at the very beginning of this lesson, phylogenetic trees help to show us the relationships between different species, between different groups. And so what that can be used for is indicating how related different species are to one another. So we've spoken about the branching, we've spoken about recent species being at the tip of the branches, and we've also mentioned that common or shared ancestors will be at the base of the tree itself. The nodes themselves represent that common ancestor, and the branch length is going to represent the splits along the way, or the similarities or the differences. So gradually over time, those with shorter branches are going to be more closely related. Those with longer branches are going to be more distantly related. So the key understanding for us is this. Closely related species will be grouped in the same part of the tree, and unrelated species will be grouped in different parts of the tree. And we can use the information that we get from our comparative DNA, we can get the information we get from different morphological features, and we can also get the information from biochemical data to help us inform our construction of these phylogenetic trees.